Okay, now wrapping up the remainder of 1.5 and we'd like to look at graphical limits, and by then we have concluded all of those. So let's see. Looking at a graph, it's a bit annoying only in the beginning, but it's very quick and efficient on the long run. So I'm looking at problem number 4 in section 1.5. It says use the given graph of f to state the value of each quantity if the limit exists. If the limit does not exist, explain why. Alright, no problem. Well, let's see. If I look at the first part, part A, it says the limit as x approaches 2. 2 is right there. By the way, I darkened the x and y rectangular, the origin, because it's kind of students lose track of where is what. There it is. If x equal 2. So when they say x equal 2, but from the left, well, on a number line, 2 from the left would really correspond to this part. So as x approaches 2 from the left, but you are on this graph coming from the left, as you get very, very, very close, infinitely close to x equal 2, what is y leveling off next to? Do you see the y? Here it's right there. As you get close, do you see that the y value is leveling off next to what? Isn't that y equal 1, y equal 2? Isn't that y equal 3? And if I redo this, but now they want me to look at x equal 2 still, but approaching that from the right side. From the right side, I'm taking this path. I don't care about any of these values. The only thing I care about, as I get very, very, very close to this x, what is y doing? Y is right there. Y is right there. As I get very close, isn't y leveling off next to 1? And now let me reiterate what I learned and see if I really got this right. That is, the limit as x approaches 2. If you remember on a calculator, we took the limit from the left, we got it to be 3. The limit from the right, we got it to be 1. What does that mean? The limit does not exist. So, how would a limit exist if the limit from the left equal the limit from the right? How would a limit not exist if the limit from the left does not equal the limit from the right? What's f of 2? That's algebra. That's saying if x equal 2, what does y equal? If x equal 2, y equal, do you see where it's included? A 3. So the fact that y is 3 doesn't tell you anything about the limit. The limit doesn't care about the value itself, just very close to it. How about this problem? How about part E? It says, find the limit as x approaches 4. How do you find the limit? You pick points to the left. Graphically, you look at 4. There's 4. From the left. If I approach from the left-hand side, what is y leveling off next to? Isn't that a 4? If I approach 4 from the right, the other side, what's y leveling off next to? Isn't that a 4? If the limit from the left and the limit from the right match, then the limit exists. And what is f of 4? This is saying if x equal 4, what does y equal? Well, did you notice that y is open circle? That means it's undefined, does not exist. So don't mix, this is what this problem is really pushing for. Don't mix continuity with a limit. That is, if the point is included, that doesn't tell you anything about a limit. And if the point is not included, that doesn't mean that the limit doesn't exist. Those are independent. One has nothing to do with the other, as far as a limit, of course. Alright? Let's look at another problem. Let's look at problem number 6. The same idea. For the given value of h, determine y, determine whether the limit exists or not, and let's see. The first, we're approaching negative 3. Negative 3 is right there. And do you notice we're approaching that from the left? The left meaning from the left. So on this graph, as I approach this from the left, what is the y gonna level off next to? This is 1, this is 2, this is 3. It looks like it's a 4. And how about the limit from the right? From the right of -3, I'm getting closer and closer. And do you notice that's a bit lower than 4, but it's approaching 4 as well. So what's the limit as x approaches -3 altogether? Since the limit from the left, the limit from the right match, we say it's a 4. That is done. Now I'm going to look at the second piece. It says, what's h of -3? When x equal -3, what does y equal? Well, that does not exist. There is no y value. It's an open circle. If I look at the limit as h approaches 0, 0 is right there. This says from the left. From the left, so as I am taking this path close to 0 from the left, y is leveling off next to 1. Okay. How about if I wanted to approach 0 from the right? From the right hand side, I am along this graph. Isn't that a -1? So what's your conclusion? Well, since the limit from the left is 1, the limit from the right is -1, as you approach 0, does not exist. So, if I asked you a limit from the left, you only have to do one-sided. The right, only one-sided. If I want you to do both, I'll ask you to do part I. Part I says, what's the limit as x approaches 2? In this case, I'm forcing you to do the limit from the left and the limit from the right. So, how would a limit exist if the limit from the left equal the limit from the right? How would a limit not exist if the limit from the left does not equal the limit from the right? Given a graph, there's 2 right there. The limit from the left, isn't that a 2? The limit from the right, isn't that also a 2? So I'll say it's a 2. Done. That's simple. What is, oh, I left a part out. What's h of 0? If x equals 0, what does y equal? So on this graph, I'm going to get rid of that so you can see it right there. Do you see it's included? So that is a 1. What is h of 2? When x equal 2, what does y equal? What do you think that point is? It looks like a 1, 2, 3. It looks like a 4. Actually, I looked at the wrong thing. Forgive me. It says h of 2, not h of 3. H of 2. There's 2. H of 2 is undefined. You could say undefined if you wish. Here it's saying, what is the limit as x approaches 5? 4, 5. Right there. There's 5. 5 from the right. Well, from the right, it's very easy to do. Coming from the right, I could say, well, you know what? It's leveling off next to 1, 2, 3. How about from the left? 5 from the left. From the left, I have no idea. And that's going to happen algebraically. They're just showing you, not every graph you could just pick things off of it and figure things out. Next problem. What is the limit as x approaches -3? Straight at it. -3 is right there. The limit from the left, if I go from the left, do you see that's going to approach infinity? How about from the right? Isn't they going to approach infinity? Since they match, I'll say infinity. What is the limit as x approaches 2 from the left? There's 2. From the left, if I take in this path, do you see what y's reaching? Isn't y, as you get very close to 2 from the left, isn't y going to shoot down to negative infinity? How about 2 from the right? There's 2 from the right side. If you take in this path, isn't that going to go up all the way to positive infinity? And then they're asking, what is the limit as x approaches -1? -1 is right there. The limit from the left is -infinity. The limit from the right is -infinity. -infinity. They say, find the equation of the vertical asymptotes. Well, we're going to talk more about that in full detail. For now, we could tell x equal -3 and x equal -1 and x equal 2. And I'll give you a hint. When you take the limit and there's an infinity involved, it's either a vertical asymptote or horizontal asymptote. If you approach a number and there's infinity, that's a vertical asymptote automatically. Positive or negative doesn't matter. Now I want to look at the last problems. It says determine the infinite limits. I do want to look at a table, and then I want to point out with a graph really quick. I don't think I'm going to have time to do all of those. At least 30 and 36 are a must. So I'm going to show you this both ways, algebraically and graphically. Algebraically, by using a calculator, I'm going to pick values of x. X approaches 5 from the left. They only want it from the left. So I'm going to pick 4.9, 4.999, and 4.9999. This is how I do it on a calculator. Then I'm going to go for a graph. And let me get my calculator out and remind you how this works. So if you remember, I'm going to take 4.9 and store that in my answer, right? And then when I get to this part, I'm going to input that in my calculator as parentheses answer plus 1 divided by answer minus 5. And I'm going to hit equal. And I'm going to do it again. I'm going to take 4.999 and now I'm going to go up and evaluate. And do you notice what happened? -5,999. And if I take 4.9999 and if I evaluate, I'm getting -59,999. So I can conclude that this limit is approaching -infinity. Alright, so if I remember correctly, -59, -5,999, and -59,999. Now, I'm going to do this graphically again. I could graph this. I have a vertical asymptote at x equal 5. 1, 2, 3, 4, 5. A horizontal asymptote at y equal 1. You know what? That's way too close. Let's say 1 is right there. I have a y-intercept at -5, an x-intercept at excuse me, at -1. The graph looks like this. And if I look at the limit as x approaches 5 from the left, guess what that is? -infinity. Now we move to the next problem. Cotangent. We have a problem here that doesn't come about in traditional cases. I'm approaching an irrational number and I'm approaching it from the left. Which point is to the left of this? Algebraically, that's very hard to do. Well, we'll get around it by, you know how when we went to 5, we went below 5, we picked 0.1 below? We do the same. We tell the calculator to do this. So from below, we subtract 0.1. Above, we add pi minus 0.01 and pi minus 0.001. See if that does the trick. And let me do this quickly. If I take pi minus 0.1, enter. And now the cotangent, I'm going to take 1 divided by tangent. Log, not yet. Tangent of my answer. And there it is, -9. I'm going to go to pi and subtract a 0.01 and do it again, 99. And if I'm going to take to pi and subtract 0.001 and do it again, I'm going to get that. Let me copy that down. So I would say that's -infinity. Graphically, a graph of a cotangent starts at 0 as an asymptote. It moves the full period, and the graph looks like this. And if I look at the limit as x approaches pi, from the left, it's negative infinity. And there it is. And there's the homework.